All right, number 7, we want to evaluate the function g of x equals 1 for the given value of x. So what you notice here is that g of x is just a constant function. If you were to graph this, okay, this is basically the same thing as saying y equals 1. So you would go to the y-axis at 1, and it would just be a horizontal line, graph straight across. Okay, so this is the x-axis right here. Okay, so this is all you get. So that means everywhere on this graph, y is 1. So when we try to do g of -2, as we just said, you can plug it in. There's no x value to plug it in. So basically it just says when you go to x is -2 right here, the corresponding y value is still 1. There's nothing to plug in, nothing to do. You just need to know that everywhere on this graph y is 1. So it doesn't matter what value of x we plug in. When x is -1, y is 1. When x is 0, y is 1. When x is 1, y is 1. X is 2, y is 1. X is 10, y is 1. Okay, along this whole thing, this graph is just saying the y value is 1. All right, so this time we're going to evaluate the function g of x equals 4 for the given value of x. So this time they want us to plug in x plus h. So we got g of x equals 4, and they want us to evaluate g of x plus h. Now, again, if I'm trying to do direct substitution, there is no x value to plug in. So g of x plus h is still just equal to 4, kind of like the previous problem. It's a constant equation. No matter what you plug in, it's going to stay the same the whole time. Number 9 tells us Joe rides his bicycle average of 18 miles per hour. The distance Joe rides, dt, in miles is given by dt equals 18t, where t is the time in hours that he rides. So we're going to do two parts. We're going to evaluate d of 4, and then all we're going to do is just plug in the 4 to this equation. So we're going to do direct substitution. We have d of t is equal to 18t, and then we want to evaluate d of 4. So that equals 18 times 4, and that will give you 72. So the miles, if he's riding, t is the time. So time in hours. So if he rides 4 hours, he's going to go 72 miles. So d of 4 is 72. Thus, Joe travels 72 miles in 4 hours, as they explain it up here. And then part B, it tells us that Joe travels 39 miles. Give an exact answer, don't round. How long did he ride? So this time they give you the y value. So the 39 miles is the d of t. So you got dt equals 18t. Okay. Then they told us he rode 39 miles, so 39 is going to get plugged in for the d of t. That's going to be equal to 18t. And we're going to solve for the number of miles by dividing 18. Okay. Divide by 18. And 18 doesn't go into 39 evenly. We could simplify this to a mixed number. 18 goes in twice, so if I'm doing long division, 39, 18. 18 goes in there twice, that would be 36. Subtract, and we have a remainder of 3. So we can say 2 and 3 out of 18, okay, which will reduce to 2 and 1/6. If I want to give an exact answer, this is the way I would write that. So mixed number 2 and 1 over 6 miles. And oh, no, I'm sorry. Totally did that backwards. We want to know how many miles he travels in 39 minutes. Please excuse me. 39 minutes. So what we're going to be doing this time, d of t, I did not read that correctly. It's going to be equal to 18 times t. Now t is in hours. So when I plug this in, this is going to be 39 over 60. So I'm going to put it in as a fraction. And we're going to do 18 times the 39 over 60. Okay. And so just doing mental math, we can divide 18 and 60 by 6. So divide by 6 and that will become a 3. The 39 will stay the same. 60 divided by 6 will be 10. And so we're still multiplying. So 3 times 39, 3 times 40 is 120. Subtract 3, 117 over 10. And again, we can do division. 10 will go into 117 11 times. So 11 with 7 left over, 11 and 7 tenths. Okay. Sorry, misread that one. 11 and 7 tenths. So we got to see almost 2 problems. Either way it was. 11, 7 over 10.